you can see from your negative sign that we're going to have a reflection. So not a V that faces up, but a V that faces down. Vertex is still the same, 0, 0. So you want to get your vertex, and then down 1, right 1, down 1, right 1. Back to the vertex, down 1, left 1, down 1, left 1. Domain the same, negative infinity to positive infinity. Now the range, if I start at the bottom, my lowest y value is a negative infinity, and go up to the top, and that's going to be a 0 with a bracket. Zeros, where am I crossing the x-axis? So that's going to be at the origin, which is 0. So I'm going to say x equals 0 or 0, 0. Y-intercept, y equals 0 or 0, 0. Now, for this guy, when you see this negative, you think, well, maybe that should face down, but he's inside the absolute value. So this is going to be a V-shaped graph that faces up. This is going to be a stretch, and that's actually going to not have an effect. So vertex, I set this equal to 0 and solve, and I'm going to end up getting 0. So there's my 0, 0. And then I'm going to face up, but I'm going to have a stretch of 2. So I'm going to go up 2 and right 1, and up 2 and right 1, up 2 and left 1, up 2 and left 1. So you can see my V got skinnier. And that's going to be negative infinity to positive infinity, 0 to infinity, x equals 0 or 0, 0, y equals 0 or 0, 0. And then we want to find our x and y intercepts algebraically. So let's go to vertex, set this equal to 0 and solve, negative 4. So I'm going to have negative 4, negative 5 as my vertex. So 1, 2, 3, 4, 1, 2, 3, 4, 5. And then he would go up 1 and right 1, and up and right, and up and left, and up and left. And I could keep going with that. And if you look, I am crossing the x-axis in 2 different places. So when I ask you to find your x-intercepts, at the x-intercept, your y value is 0. So we're going to take this equation and we're going to say, okay, 0, x plus 4 minus 5, and then we're going to solve. So add your 5 to the other side. And this is material that we've had since the first test. Make 2 cases and then solve. So this is going to be a 1 and this is going to be a negative 9. This is the point 1, 0. This is the point negative 9, 0. That looks like 1, 0. That looks like negative 9, 0. And let's get those listed. And then we'll find, I'm doing this a little bit out of order, the y-intercept. At the y-intercept, I know the x value is 0. So if I just plug 0 in, whoops, that's going to come out as a positive 4 and then minus 5, so that's going to be a negative 1. Zeros, same as your x-intercepts. It's just a different vocab of where am I crossing. So 1, 0 and negative 9, 0, where I'm crossing the x-axis. Domain, that's a no-brainer. Range, I'm going to take the y value of the vertex every time and use them. Negative 5 to infinity. And then I'm going to have you guys try this one. But if you want to look at Desmos, I'm going to give that a try. I've got him ready on there. I just hope I can get it videoed correctly. Okay, so here's my Desmos. I've got that one typed in here. One thing you might want to learn on Desmos is hit this guy and then go to your table, and then you get an entire table of values, and the vertex sometimes may or may not be in there. So here's my vertex. He's not in the middle. So if I want another point, like let's say I wanted an x value of 5, just type your 5 in. It automatically adjusts your y value for you. And then if you look at your graph, one thing you can see, I'm not touching the x-axis on that one. So that means I'm not going to have any x-intercepts. And you can zoom in. You want a y-intercept, just mouse over them, and it says the y-intercept is 0, 12. So Desmos is a very nice feature. Will not be used in next year's math classes. It will be used in our class and on formative assessments and the SOL.